Hello. So I hope you had enough coffee during the break in order to stay awake for the next 50 minutes because I have a lot of slides for you. My name is Patrice Krakow. I'm working at ING as the lead architect of the API platform. I guess that most of you know that ING is a bank, and for the one who did not know, now you know. But I'm not here to talk about this good old bank, so let's remove this picture. I'm here to talk about APIs, web APIs. But before that, if I may, let's check if you are actually awake. I have a few questions for you. So could you please raise your hand if you have at least one current bank account? Wow, all the hands. Please stay with your, because now the trick is that please keep your hands as long as you can answer yes to all the questions. So in order to manage your bank account, in order to make payments, to check your past payments, do you use a web or a mobile application? Great, so no one is using paper form anymore. Now, the real question, who has at least two current bank accounts from two different banks? Still a few. And if I'm right, in order to manage those bank accounts, you have multiple applications, right? Yeah, correct. How do you like to make banking with different applications? No one. Great. And I have a good news for you, because that annoying experience should stop thanks to PSD2. Who has heard about PSD2? Wow, quite a few people. So PSD2 is a European directive, the Payment Services Directive 2. So not only the Hollywood movies like Blade Runner goes for a version 2, but also the European directives. But I'm not here to talk about it. So very quickly, this is about the obligation for banks to open bank account information and payment initiation through other banks or fintechs. So it will be possible to create an app with which you will be able to manage multiple bank accounts from different banks. And that will be probably done via web APIs. But I do not want to concentrate on PSD2. PSD2 is not that interesting because PSD2 is what we are obliged to do. At ING, we do care about web API because of this. Because we want to be part of the world of tomorrow. We want to be part of this world where you do have an ecosystem of businesses and where customers have experiences that go across the barriers, the traditional barriers of businesses. And this is really going way beyond this idea of digitalization. We do not want to digitalize our existing banking business, but we really want to transform ourselves. And I would say that at ING we have the chains, and I personally feel lucky that we have this visionary CEO, Ralph Hammers, who recently declared to journalists that he wants to transform ING in a tech company with a banking license. And by the way, last word about ING, and then I will stop. In order to achieve this transformation, we are recruiting. We are recruiting good developers, good Java developers in particular. And we are really proud to be a platinum sponsor of this fantastic Devoxx event. And I hope to see you all at our conference stand downstairs. But as I said, enough about ING. Let's talk about something much more interesting. Let's talk about me. So just kidding, this is just a brief introduction about myself. Details are not important. Just be aware that I'm working for the past 20 years within the integration area. So 20 years, yes, I'm quite old. Hopefully with some technology that you have never heard about, unless today where I'm now focusing on this REST APIs. So now, time to dive into the subject, APIs, and I've picked up one of the subjects that I prefer and one of the most debatable subjects, which is the versioning of API. And traditionally, if you Google API versioning and you have an article, it will start about how to version. Do I put the version here? Do I put the version there? And this is exactly what I will not do today. I want to step back a bit and ask ourselves why do we need to version? And by the way, this is the book I'm currently reading from Mike Amundsen, and I will definitively encourage you to follow this guy if you are interested by web APIs, not only about the versioning. And so the idea is really to go back to the why is it important to care about the versioning of API. And when we talk about version, we are actually talking about changes. How do we handle change over time? And again, let's asking ourselves why. Why is it important to handle this change? Why does it change? And a way to answer that question is to say that because there is a tension. There is a tension between, on one hand, the API provider, and on the other hand, the API consumers. As an API provider, what you want to do is to change your API as soon as you have a new brilliant idea. That's what you want to do. And from an API consumer, you want your API to be quite stable, unless you are interested by this new brilliant idea, of course. Talking about API versioning, there is also a well-known best practice coming from Roy Fielding, the father of REST. So if he's saying something about API, that should be something interesting. And what he is saying about API versioning, you probably all know, is don't. And that is actually nice, but it's a little bit short. When I go to the squads and they are asking me, hey, Patrice, how do we version our API? And I say, don't. They feel a bit, okay, missing something. By the way, this don't comes from a really famous keynote. It's already from 2013, and you can see here the original slides. Unfortunately, I have not found any recording of it. If you ever find one, please let me know. One of the important things now, in order to continue, I already need to pause a bit and to talk about some terminology, about some meta model, because this is really something that we have find out within ING when we started this one year and a half ago, is that it was extremely difficult to discuss specifically about versioning because we were not talking about the same thing. And this is why I will start with a result of this work that we have done 1 year ago about meta model and terminology, which is still evolving. First of all, and maybe above everything, we make a radical distinction between the API being solely the interface and the implementation of it, the code that implements that API that we call a service. And I would say, I mean, with all the ASM presentation that you will see all this overwhelming information, you will probably not remember a lot about my little presentation. But let me get a chance right now that if you would remember one and only one thing about my presentation, it's this. Please make a radical distinction between the API being solid interface and the service. That's it. So I still have 40 minutes, so I will continue. The real atom of in our API terminology is not the API, but it's an API endpoint made up of a HTTP method, a host, and a URL path template. And when you write a program, you do not call an API, you call an API endpoint. And then what we call the API is just a set of API endpoints that share a common purpose. Then you have the API specification, which is the description of all the API endpoints that are part of that API. And we are quite lucky nowadays to have a winner standard for that, being this Swagger, also known as OpenAPI. But I will come back to that later. And then we have the service, which is the actual code. It's the things you put into your GitHub repo. Which implements one or multiple API endpoints. We also put this additional constraint, which is not necessarily needed, but I just wanted to share with you that a service can implement different endpoints, but all these endpoints should belong to the same API. We do not have a service that implements different API endpoints coming from different API. Then we have the version of the service. When you have your code into your GitHub repo, you version it, you tag it, and then you deploy it, and you have what we call an instance. So the instance is the running process, the things which is actually listening to an IP address and a TCP port. And that makes our now common terminology. And now I can talk about version. And why is this important? Because I will not talk about a version, but I have two different versions. The first one, which is quite obvious, it's already there, that's the version of the service, the version of my code. And I will also version the API specification. And I need these two because they can be independent. You can fix a bug into your code that does not trigger any change into the API specification, and vice versa. You can fix a typo into the description of your within your Swagger that does not require a change into those services. So these two things are two different versions. So normally from now, I should never talk anymore about the version of the API, but I should specifically talk about the version of the service implementing the API or the version of the API specification describing the different API endpoints from the API. You see that we are both using semantic versioning for these two. I guess you are all familiar with this idea of the semantic versioning from the founder of GitHub, where you have these three numbers, X, Y, Z, X, Y, where you increment the Z when you have a backward compatible bug, you increment the Y when you add a functionality in a backward compatible manner, and the X if you are not backward compatible. The interesting thing is that it perfectly fits because this is about the version of the service, and it explicitly refers to an API within the semantic versioning specification, but it's not really precise in terms of API. It's quite open. And in our context of the web API, we are again lucky that a very easy way to be precise and comprehensive is to use Swagger. Alors, the usage of semantic versioning for Swagger itself is maybe not that obvious because it's not a software. So maybe we would have to adapt a bit the semantic versioning specification, but this is way too much text. Let's just focus on two things. So as I already said, the Z of the service and the API specification are independent from each other. And if you promote an API design first, you could see that the why of the service is following the why of the API specification. So please keep that in mind for the rest of the discussion. And now I can introduce our journey to the zero downtime. So we have started with this meta model. I will now introduce to you our API gateway, API service discovery, and API registry, which forms our API platform. Then we will talk about the idea that whatever problem we have, it's a problem of routing. And we will implement the routing needed to go to make a Canary release, which is on our way to the zero downtime. And to be honest with you, I will stop in this presentation with the Canary release being one part of the zero downtime, but all the other special routing that might be needed, we should be able to accomplish them with this platform. So let's start with the API gateway, API service discovery, API registry. The most easy one, the most classical one is the API gateway. So we are still making a distinction from a network perspective between inside ING and outside ING, and we put a gateway in between. Within ING, we also make a distinction between, let's say, the data center and the office being this network zone where the laptop of the employees are running, and we put also a gateway there. And we call the first one the API gateway on the external edge, and the second one the API gateway on the internal edge, and not the internal API gateway, because inside, within the data center, in terms of communication between services through API, we put nothing. There is no gateway, no load balancer, no proxy, no HA proxy, no bus, nothing. Just a pure peer-to-peer TCP connection. And when I say that to a traditional, middleware architect or engineer, he say, yeah, but how do we do the logical addressing, or do you really need all the service to know the IP addresses of all the other services, and how do you do the load balancing? And the answer is that we use a service discovery. So the way it works is that we start with an API, and let's say an API endpoint. I will represent this API endpoint with those three characteristics: the HTTP method, the host, and the URL path template. And then I have the service. So you see that I try to have a notation which is consistent with this clear separation. The API is just this little circle, and the box is the service which is implementing an API. We start the service and we got an instance. And what is the first thing that an instance is doing is that it registers to the API service discovery. And by the way, you should here tell me that this drawing is not really nice, because one of the important rules that we try to apply when building this API platform to help the services to communicate is to eat our own dog food. So the API service discovery that I have shown is a service which is also exposing an API. So this drawing should be drawn like this. What does he do? So the API service discovery, you can just see it as an empty database, and the instance is sending the logical name, being the API endpoint, together with the physical address, being the IP address, and the port, so it can reply to a code, to something which is addressable. So let's put some some application, and let's isolate a part of the code that we call the router. I will come back to that also. So what does the router do? When I code my application, I code that I want to call this API endpoints. That's what I find into the API specification. I pass it to the API service discovery, which associate to it the physical address, and then I can have a direct call. So this is the way we have a genuine peer-to-peer TCP call, but we do not need to know in advance within our application the IP address of the targeted instance. Regarding the load balancing, if you have a second instance of that service, it again registers, and this time if the application is asking the same question, it will get two responses, and it will be able to make the load balancing in between. And usually when I show that, people are saying, okay, let's have a look in more detail. So let's remove this. Let's focus. I have here the same thing. I have here the same thing. Here it's also the same. So what do I have? Something that looks like a DNS name and two different IP addresses. Should do that with DNS. And by the way, this is still a subject when you are talking about API service discovery. You still have a lot of people asking, why don't you do that with DNS? And here I just want to take some time to go to a particular example to show you that DNS is not sufficient. I will not be exhaustive, but let's just take a little example. Again, our meta model, let's clean it a bit. So I have API, let's say that I have two API endpoints, which are part of an API, but this time I will implement each API endpoint in a particular service. And let's take an example of that. So I have this get payments that will give me the list of all the payments I have done. And I will have a post payments, which allows me to initiate the payments. And let's say that I will implement that into two separate codes to GitHub repository. And by the way, this is making more and more sense. I think you know, or you will hear, I have seen a few conferences here talking about CQRS, event sourcing. It makes more and more sense to completely separate the writing part from the reading part. So let's say that we have this. We instantiate those two services. We have our API service discovery. The first one register, the second one register as well. Now I have my application. So let's imagine that this is my mobile banking application, which gives me the list of all the transactions, but I can also initiate a payment. So I will start with having the list. I will call the service discovery and get the address of the first instance, and I will have the list. And if later I want to initiate a payment, I'm asking for the post payments, and I get the address of the other one. And if you look now at what you have here, you see that the mapping you have to do is between the method and the IP address, not anymore between the host and the IP address. And basically, you can have all sorts of combination, and this is where DNS is not sufficient to have this kind of flexibility. Alors, you do have, of course, the option to tweak DNS to add more records and those kind of things, but then you do not have really DNS anymore. API service discovery and client-side load balancing. I went to a few talks here, and I hear about this client-side load balancing, server-side load balancing, and I would say that here I will be a architects, and I will clearly say that I really have a preference. I really do prefer this client-side load balancing, and that's something I would like to share with you. Talking about me being an, why do I say a bad architect? Do I have some architects in the room? So people who have architects in their title? Quite a few. In the other one, is there any people who would like to become an architect? Because if yes, don't need to answer. I can give you the trick. That this is a typical question you got: client-side load balancing, server-side load balancing. And as an architect, you should not answer. You should pause, think, and then say, it depends. So here, I do not want to say it depends. I want to say I love client-side load balancing, and here is why. So you have here two equivalent situations, one with server-side load balancing and client-side load balancing. You have 4 services, or microservices, you may say. And what is happening with such an infrastructure is that the system grows and you have more services. And then what is happening? When you have a server-side load balancing, what is happening is that you put more pressure on your server-side load balancing. The computing of the balancing is increasing, and that can become a bottleneck. That will become a bottleneck in your entire system. And yes, you can cluster it, you can augment the capacity, but that's something you have to care about and you have to be careful about. While on the other side, each node is coming with his little capacity of balancing, which will be enough for the entire system. And this is where, on this side, we can say that we have something like a self-provisioning system, and not self-provisioning in the sense that you have to increase the capacity, but no, by design, when the system grows, the capacity is nicely distributed. I highly recommend you to read this little article. This is really that has really been for me the eye opener, and I hope it might be the same for you to promote load balancing and being a bad architect and not say it depends. Last one, the API registry. Again, my API or API endpoints, and I have always worked with this little ad hoc notation. But as I said, we are quite lucky thanks to Smart Beer. That is a software company which is there for quite some time. They were the one behind SOAP UI, so at the time that SOAP was an interesting integration technology. But they are the one who have also come up with Swagger. And when I started 1 year ago, I would have a completely different speech here, because there was a war between Swagger, ABI Blueprint, ARAML. But now I think it's done. Swagger has won, and they have moved their specification to the Linux Foundation, which has renamed the Swagger by Open API. And be careful, Open API without a blank. Don't know if you have noticed, but we start to have a kind of a strange relationship with these nouns which are glued together without the blank anymore in front of it. I would say that within this conference, and it has been quite some time like that, I'm really quite happy that we do not have any problem anymore with this microservice being microservice without a blank and not with a blank. And we now start to have probably the same kind of confusion around Open API, where you have the Open API without the blank, which is the Swagger, and the Open API with the blank, which makes sense, but which is something completely different. It's usually something we use to say that it's an API which is accessible outside of the network of the company via the gateway. Whoops. 20 minutes. So, Open API without a blank. Yes, for the moment, there is already an API, Open API version 3.0, but at least at ING for the moment, we stick with the Open API 2.0, which is equivalent to the Swagger 2.0. And this is how my little triplet here will be put into a nice Swagger. And those things are exactly what we put into the API registry. So we have a database with all the description of all our APIs. But not only that. So let me take back this little drawing. Two things here which are extremely important. The API and the service are two different things, but they are linked. An API is implemented by a service, and a service is exposing its functionality via the API. And when you have such an automatic runtime registration to the service discovery, the question that you could ask is that allowed? Is this service allowed to implement this API endpoint? Otherwise, it would be too nice. I go to the API registry, I take the Swagger of the payments API, I make my little services, I register to the API service discovery saying that I implemented the payment API and I got the money. So something very important that we store within the registry, and more classically also when an application is calling an API, we have to know, the service needs to know if this application is actually allowed to do that call or not. And these two things, we store them into the registry in form of what we call the manifest for the authorization to implement, and that we call the subscription or a peer token for this authorization to consume. The manifest. So let's go back to our terminology again. This is the thing that we put between the API endpoint and the service. That is the things that makes the link between the two. And one thing that will be important, just try to keep that in a corner of your mind, that when we create a manifest, at that moment, the API endpoint is described by a particular version of the API specification. And that particular version, we store it into the manifest. We pin it into the manifest. So the manifest will remember that at the moment this service was implementing this API was described, this API endpoint, was described by this version of the API specification. To fix the ID, we put the manifest in a simple JSON structure. So if we go back to our little example with the Swagger, this is the way we can easily populate the manifest. So it makes the links between the service via its name to the list of all the API endpoints that this service is implementing, and it remembers the version of the API specification where this API endpoint was described at the moment this manifest is created. Now the other one, the authorization to consume the subscription. So the ID within our API platform is that if a piece of software wants to consume an API endpoint, it has first to declare it. And this piece of software who wants to call an API endpoint, that's what we call an application. This is a traditional name used in most of the API developer portal. So this is something which is done at design time via a user interface. Again, there is this little trick to pin the version of the API specification which is describing the API endpoint at the moment the application subscribes to the API endpoint. Again, that will live into a peer token, and you can see that we have really a similar structure than for our manifest. But this time what we store in this is that. So here I have a subscription that will be later approved to this get accounts. So that the application one can have access to the get account. And by the way, at the moment that subscription was done, the get account was described by the version 1.0.1 of the API specification. So we have them all now. I will just redraw the whole thing together and in parallel with the component and the meta model. So we start by our API endpoint, which is part of an API described into an API specification, and that's what we put into the registry. Then, the way we put that into the registry is via the API developer portal that you can see as the front end in front of the API registry. And by the way, again, this API developer portal is just an application calling a service, which is the API registry via its API, which is the API registry API. So I should draw it like that. The service, so the code behind the API, which gets this manifest from the registry. Manifest which is pinned with the specification, API specification version. The service has the version, and that's the API provider. The instance, which is the running instance of a specific service version. And the manifest, by the way, is something that can be acquired at runtime. The API service discovery, the application. So that's the classic interaction. Here, the peer token, which is the which contains the subscription which is given at runtime by to the application. Again, this pinning. And here I will introduce the last one, which is our API SDK, because this router part, so the way the application is interacting between the API service discovery and the API registry, and also the way the service is interacting within this the API service discovery. We do provide libraries through an API SDK to help developer to develop that properly. But on the other hand, it's just REST API, so you do not. It's really a help. You do not need those libraries, and then you can make the call. And the idea here is that with a router, which is a part of the code of the application, who has access to both the API service discovery and the API registry, we have all the ingredients so we can make routing decision that will allow us to go via this zero downtime status of our system. I have insisted a lot of this pinning, and this is indeed actually what is important, and that's what I will describe now for our Canary release. I will just quickly go through. So, what is a Canary release? So, the idea is to expose a change in a gradual manner, not in a big bank, but just a few. And this terminology is coming from this habit of the miners, that when they go to the mine, they take a canary with them. So if there is a problem, like a gas leakage, it will kill the canary before the miner, so they have time to escape. So it's this kind of early warning that we would like also to have in our system. We want to introduce the change, and then if something goes wrong, have an early warning about it. And all this terminology, by the way, is coming from the Martin Fowler wiki on Canary release. And he's describing the Canary release this way, that you have an application calling an instance of a service via a router. You introduce a change that does nothing, and then you gradually expose your system to that change, and at the end you can decommission the old one. And if you have something wrong during all this trajectory, the rollback is extremely simple. You just redirect to the old one. And the idea is that with the platform we have, we can do that. And we can do that including some annoying scenario. So imagine you have your application calling your service, and that has been done at the same time, so you have the same version. Now you introduce a change into your service, a backward compatible change, so you can expose your application to this new service. And of course, the idea is to get rid of the old one. But I can tell you that within a big organization, saying that Canary release should last only 1 day or 2 days, you will always have a good exception for that not being the case. So let's imagine that this old service stays for whatever reason, but then comes the pressure to have a new application that will, of course, register to the new version of the service. And this is where you start to have a problem, because you do not want to have that. If you have the new application, so which is expecting the change from the API endpoint, so for instance, an additional field into a response, if we direct it to the old service, there is a change that it does not get the answer that he's expected. So this is something we need to avoid, but we can avoid that. Alors, how can we avoid that? So let's go back. This is my last animation. So I start with an API endpoint, which is my get accounts, and that one is described into a Swagger of version 1.0.3. Here it is. And that is something that I put into the registry via the API developer portal. Now, my service, my code, which gets the manifest, the authorization to implement it from the API registry. So I will save that here. I will instantiate my service. My manifest can come at runtime. My API service discovery, you already know the story. Now, I will send the physical address together with the logical one, which is, by the way, just the manifest, the list of API endpoints that this instance can serve. I will save that in a corner. And I will now introduce my application. The first thing the application needs to do is to subscribe to the API endpoints. This is done at design time via the API developer portal. This is the peer token that will be generated. So I instantiate the application. I have this router, which will get this time at runtime the peer token. And then the router calls the API service discovery and gets the physical address. And now the router has all the information that he needs to make the correct routing. The two versions match, so he can safely redirect the call. Now let's continue. I make this change to this endpoint. So I have a new Swagger. I make a new version, new instance. I got this new manifest. Can you still hear me? Yeah. Okay. Where am I? The manifest. Then, yes, it registers to the API service discovery, the known story, which means that when the router will request again the API service discovery, he will get now these two instances. And here you will see that you have a new instances, which corresponds to a service which have been created when it was a newer version of the API specification, but a backward compatible one. So I can safely direct as well. And then I have this situation with my old service and my new service. And here comes the new application, which subscribes to the new version of the API specification. Again, same thing, I have this subscription that will be transferred at runtime as the peer token. And I will ask, when I will ask the API service discovery, I will get the exact same response. And this time, again, I have all the information. I should not redirect to this instance because there might be a chance that the application will not get what they want. And I direct to this. So here it is. As a summary, make an explicit distinction between the API endpoint and the service. And I still have 3 minutes, so I can continue. Use the semantic versioning for both the service and the API specification. Make an explicit link between the service and the API through this manifest. Use this API service discovery to register your instance at runtime. Have an explicit subscription that can live at runtime as the peer token, and enjoy the fact that they have a similar structure. And then your router can make a wise decision. And the conjecture here is that this mechanism can be extended to other routing techniques, such as other strategies for Canary release. Here it was just a random 10%, but you can do a Canary release with a selected set of users, confidence check, A/B testing, and so on. So, final conclusion, make an explicit distinction between API and service. I have been a teacher in a previous life, and I know that repetition is the mother of all learning. So if you have to remember one and only one thing, this is this. And as a conclusion, API versioning, don't bother your customer with it. Thank you. So I have 1 minute left, so I can maybe take a few questions. Or you just join at the stand downstairs from ING, and I will be there to continue the discussion. Thank you very much.